me to start? Okay. Okay, guys, I'm going to call you guys to attention now. I know you guys have been in MY 150 before. It's a bit of a loud room, so it's tough to get everyone down. So if we can get everybody to quiet down a little bit, and then we're going to get started. A brief reminder for those of you who are new to the room or haven't been here before, remember this is an active learning classroom, so we're going to get you to speak through the mics, and if you remember, if you want to respond to something that we ask you about, press the back of that microphone. If you found that you've done it as an accident, you kind of hold that button for a little while and it should turn off, right? It should turn red if you're signaling that you want to talk, and it should go green as your mic is active, okay? So welcome to ece297. My name is Alan Chong, and I'm just going to introduce Professor Von Betz to start off this lecture.
Thank you, Professor Chong. I think and I hope that you're looking forward to this course as much as I'm sure Professor Chong is, and as am I. Design is important, and so is communication. So I can't really emphasize too much the importance of both.
Well, I have to cut you off now, sorry. We talked about this. We talked about how important communication is, and we were going to do better this year in communicating to the class. Can anybody give some feedback to Professor Betz about his communication style and how he might improve it? I see D14 has their mic on. Is that a purposeful one, or is that unintentional? D14, any ideas about how Professor Betz could improve his communication style? Speak into the mic if you can.
Less pausing in between sentences.
Less pausing between sentences. Okay, other ideas about communicating more effectively. I see F07, so I'm just going to turn you on.
A louder microphone.
Sorry, what?
A louder microphone.
A louder microphone. Okay, so obviously his volume wasn't that good either. Any other ideas about how to improve that communication? Okay, we have F08 up there as well.
More open body language.
More open body language, so not looking like this and away from the audience and engaging the actual audience. Okay, some really good suggestions for how to improve Professor Betz's communication style. As you'll see shortly, that's not how Professor Betz usually lectures. He's actually a very effective lecturer, but we wanted to start that out by just giving you a sense of what the impact is when somebody doesn't do a really good job of presenting or delivering content in front of you. Now, I know you've been in a lot of lecture classrooms already where, you know, the standards might not be perfect. Hopefully they're better than what we just saw. I'm going to turn myself down a tiny bit because I feel like I'm a little louder than I want to be. But it's really important to see the impact that a communication style can have on how people understand you, how people think about you as you're communicating with them. Okay? All right. So why did we start the course off that way? Well, partially it was to make that message clear. Partially it's also to show that introductions really matter. So one of the things that we're going to teach you about communication in this course is that introductions are really key. They're key to establishing your credibility. They're key to establishing your audience's understanding with the material and also their engagement with you as a speaker. So if we go to the literature on communication, communication. There's lots of it. And we look up what are the what's the role of an introduction? And we go to this kind of really old article where, from 1998. We can see that there's a series of things that a good introduction can create, right? So they did a study of a large audience sampling of how people responded to different introduction techniques, okay? And we saw that a good introduction makes an audience more likely to listen to you, okay? Think more highly of you as a speaker, and then also understand what's coming out of your mouth or your speech a lot better as well. Now, what's really important, and why I stopped Professor Betts before he went over this mark, is that this judgment is usually made within a single minute. Okay, so it doesn't take a lot of time to create an important first impression, and so that's one of the reasons why we want to make sure that you're thinking about your introductions especially hard in your oral presentations and also in your written documents. Now, another reason I wanted to start with this was just to start to show you that technical communication or engineering communication is not just something we teach in engineering schools without a kind of theoretical framework. It's also a field of study, and it's a field of study with its own academic journals, so that's one of them, but I've just brought out a series of 6 different journals that are focused primarily on engineering and technical communication. Okay. Now, I know that you guys have already had instruction on communication in the past, in APS 111, 112. And part of what I'm going to do today is talk about the difference between what you did in that class and what we're going to do in ece297 as we think about more different types of communication and also different contexts for that communication. But what I do want to show you here is that the things that we're teaching you in this class are grounded in research, okay? So technical communication is not just a set of principles that we teach. It's actually something that is studied and researched and is evolving as we have different platforms for communication. Just like software or hardware engineering, right? Obviously, there are not as many journals as there are in engineering, but certainly there are quite a few journals. And really what the reason why that there's such an active field in studying communication is because of how important it is to, say, an industry like engineering, okay? So if you look at some of these documents, so this pile of types of documents that you will see over the course of your career, these are all the places in which you're going to be practicing these communication principles over your career as an engineer, okay? And not only are you going to be practicing in kind of formal communication contexts, you're going to be doing it a lot in informal contexts, right? Just everyday group communication, a quick informal presentation to your boss, all over the place. So all of those places, you'll be practicing these sorts of techniques, okay? And engineers themselves, certainly practicing and working engineers recognize that this is really important, okay? And how many of you have heard about the IEEE or know about the IEEE? Okay, so quite a few of you. How many of you are members? Not very many, okay. So the IEEE is an important organization for engineers, especially computer and electrical engineers. It's a professional society for electrical, computer engineers, and electronics engineers. And what they do is publish a lot of research. They do a lot of training in different fields. They run a lot of conferences and meetings. They publish standards, right? You'll know that IEEE is responsible for Wi-Fi standards and a whole bunch of things like that as well. And they're a huge multinational, international, billion-dollar organization with over 1 million members, okay? Now, there is a branch of IEEE at the University of Toronto. Anybody here a member of that student branch? you should become members, right? It's an important society for you to join, especially given your discipline, and especially given the fact that they run and host events for students like this largest Make-a-thon in Canada that's happening in February. So keep in mind that that's something that's going on, okay? But within this larger engineering organization that's focused around engineers, there are a lot of smaller subgroups. So there's a communication society, there's a reliability society, but there's also within this group a professional communication society. So within this IEEE engineering group, there's a group of us who are responsible for training and research and conferences and meetings and setting standards in professional communication. And those of us who are essentially practicing engineers who do communication in their work, we're academics who teach in the field of technical communication or engineering communication, or we're practitioners. So that's people whose main job it is to do technical communication within a company. Okay, so within that larger group, we have this ProCom, Professional Communication Society, which runs a lot of interesting things and has a bunch of resources for you to look at. Now, one of the things you should note is, at all of these make-a-thons or hackathons or design communications, what is the final product that you're producing? It's usually an oral presentation or a document. You hardly ever get to the final design. And so the principles that we're concerned about in this part of the IEEE is something that gets applied in every other IEEE group. And so we work with all those other groups as well, okay? So if you go to our website, you can see that we have a bunch of resources that are available to students and engineers to kind of improve their communication. You'll see that we have a journal called the Transactions on Professional Communication, and then we also run an annual conference where we discuss trends in communication practice in engineering and a variety of different things there as well. Okay. Again, if you look a little bit closer to on our website, we have a lot of material that you might want to look at, which is related to what can practicing engineers or engineering students take away from our members' research and teaching practices in the field of engineering communication. Okay, so what can you take from what we're doing as academics and researchers? Okay, now I'm bringing this up and I'm saying us, because this is very much my community. This is where I come from. So I'm a member of the Professional Communication Society. I contribute to some of those journals there. I've been a faculty member in the engineering communication program in engineering for about 17 years. I'm currently the director there and also the associate director or undergraduate for ISTEP, which is the Institute for Studies in Transdisciplinary Engineering Education and Practice. I know that's a mouthful. I'll tell you a little bit more about that later, okay? And I've done a lot of teaching throughout a variety of different departments in engineering, from Civ and Min to engineering science and ECE, of course, okay? Now, before that, I worked as a communication consultant in Trainer in a variety of companies. Some of these are Hatch, CGI, or Autodesk. And what I did there was I ran courses training their employees how to communicate a little bit more effectively. And I still do that kind of on the side a little bit. I mentioned ProCom in particular because right now I'm serving as the president of that society. Got one more year in my term, and I'm always interested in hearing how, as a society, we might be able to best serve our constituents, and that includes the students at U of T. Okay. Anyways, I'm excited to get started teaching communication with you within this particular context, and I'll hand it over to Professor Betts. Yeah.
Can everybody hear me? Okay, I was carefully studying Professor Chong. I'm going to try to apply some of his communication techniques in the remainder of what I talk about today. So hopefully I do a bit better. And let me connect in my laptop here. Let's see if that works. Okay. So just as Professor Chong is, I'm excited to be teaching this course. I think that the mix of design and communication in this is a lot of fun to teach, and I hope you enjoy it to learn. Let me quickly give you my bio. My professional career has been now almost exactly evenly split between industry and academia. I co-founded a startup to commercialize my PhD research. We built computer-aided design tools, so very complicated software tools, and also hardware architectures, so computer chip designs themselves. I spent 11 years after my company was acquired by Altera, which is now part of Intel, at their Toronto R&D lab, ultimately leading the lab and being senior director of software engineering. So by the end of that, I was leading a team of about 100 engineers. And I've now been a professor for, it's actually slightly out of date, it's now 12 years. And I've led, my research includes a lot of large-scale software projects as well as hardware design. And a lot of those software projects are open source ones, where we collaborate with various other developers around the world, using open source tooling and techniques. So why am I telling you all of this? Well, because I think it is helpful in some of the things we're trying to teach you in this course. How to complete complicated designs, how to manage teams, how to manage projects. I've worked in moderate-sized teams at a startup, large-sized teams at a big company, and then in more disaggregated teams for open source development that's happening around the world. Okay, so what are the goals of this course? So I'm going to get you guys to this room is really loud, so it's going to be a pain that I'm harping on this, but I'm going to call on you guys to please not chat amongst yourselves while I'm talking, because even though you're set up in these nice conversation nooks, it makes it really hard for people to hear me. Okay, so thank you. Okay, so we've got a few different course goals. First, learn how to complete larger designs, learn how to manage projects. You're gonna work in a team. We're gonna teach you agile software development techniques, which are kind of the state of the art. Enhance your communication skills, as Professor Chong talked about, both oral and communication, and especially make things memorable, and learn some of the tools of the trade in software development in particular. So lots of what you're learning about is gonna be applicable to all sorts of communication and design challenges throughout your career, but we're also going to dig a bit deeper in software using some of the latest tools. I'm not going to go through them all. Also how to architect software, choosing the right data structures, some fundamental algorithms, and the fundamentals of graphics. So a pretty broad menu of what we're trying to cover. The basic learning is going to occur in lectures and tutorials where we teach you the basic principles and key information. Can't force you to come to them, but the project is much, much harder to complete if you do not actually watch, or better yet, attend the lectures and tutorials. There's a course textbook that Professor Chong will talk about more in a few minutes called Made to Stick. You're expected to read it and know at least the first 6 chapters of it, which is the core of it. Why am I telling you that? Because you're going to give presentations, and at the end of those presentations we ask you questions. Basically everything from the lectures, tutorials, Made to Stick book is fair game. So we aren't going to ask you really tricky, detailed things, but we expect you to know the big picture of all of this. Okay, so to learn more, you have to learn by doing. Okay, so we're going to teach you some basic principles, but you have to apply them, figure out how they work for you. So you're going to work in a team of 3. You're going to develop a complicated C++ software application. You're going to communicate effectively. The more effort you put into that, the more learning. So if you do the minimum, you won't learn as much. At the same time, a project never ends. It's never perfect. A presentation is never perfect. So you have to balance. You have to decide what's good enough. And that's not an artificial thing. You actually have to decide this in your career too. too. When you're out working, if you polish some presentation for 6 months and don't do the rest of your job, it's actually not good. Now, if you actually create a key presentation in the last 2 minutes before you deliver it to the CEO, that's probably also not good. You have to find what the right balance is so you do okay in your other courses too. We do not expect perfection. We know it's not achievable, so don't strive for that. In the lectures, we're going to cover the key concepts, but we're not going to give you every answer, because part of this deeper learning is you have to discover some things on your own. You have to overcome some challenges. So by completing a project, you're going to hit some difficulties, but that teaches you how to learn more, how to work more independently, builds confidence to work in open-ended systems. So I told you I started a company, I led large CAD teams. I could not have done that when I just left undergrad. And I couldn't have led the size of teams and scale of projects that I did later in my career, earlier in my career. I was the same person, but I gained more skills and also just more confidence. By overcoming every challenge where something's hard, it's difficult to get working, and you still make it work, it builds your confidence that you can take on challenges where at the start you don't quite know how it's all going to work out. These challenges in this course will not be as large as those you face in your career, but we're giving you a taste of that. They're bigger than what you'd have in a lab. But by overcoming them, you develop that tenacity of how do you make something difficult work. Okay, so I'm going to very quickly talk about two of the other course goals and why they're important. So communication, Professor Chong has already talked to you about why it's important. Software, I've already given a couple of seminars in 201, so I'm not going to go through this again, but hopefully I think all the people who chose this course probably believe software is important. It's in everything. Computers, TVs, it's in embedded systems like microwaves and airplanes and cars. It's running our data centers, where we're getting our web searches from, where our languages are being translated. It's behind the deep learning algorithms that are enabling that machine translation and generation of text and images. It's used to actually create all sorts of products where it doesn't ship in the product, but it's used to optimize things like MRI machines, computer chips, etc. So you're going to use it as an engineer no matter what. And it's the method by which we automate repetitive tasks. So the last computer chip I worked on before leaving Altera had 4 billion transistors. Nobody wants to choose how big they are by hand. You write a program, and it optimizes the speed and area of the chip by choosing the right size for every transistor. And you can't buy that program. We had to write it ourselves. Okay, so that was a really, really quick view of software's all over the place, because I think you've seen it before. The other reason you want to focus some on software is, well, so it's really important. You also get better at it with practice. Okay, so I want you to read this quote, and I'm gonna basically see if anybody can identify it. So hit your microphone if you think you know who made this quote. And I'll give you a few seconds to read it. Okay, so if you think you know who said this, okay, so A09, wait, did you look it up on your cell phone or not? Okay, so I'm gonna go to you. We'll turn on your microphone. Okay, so A09, do you know who did it?
Yeah, Bill Gates.
Did you look it up or did you know?
Yeah, I looked it up.
Oh, you looked it up, okay. But he did show the power of software, right? So he didn't actually know the answer, yet he knew that if he used a smartphone and some machine learning that's in the web search behind it, he could get the answer. So we'll commend him for that. But yeah, this was Bill Gates. So this is somebody who knows, quite a lot about software. Bill Gates, I mean, everybody here I hope knows who Bill Gates is. Is that correct? The world moves fast. Sometimes you go like, maybe people are forgotten. Obviously, he was an incredibly skilled software developer, founder of Microsoft, leader of Microsoft for many years. So he obviously had a lot of business acumen, but he also was a very skilled software developer. And the reason he was a very skilled software developer is that he had access to the University of Washington mainframes when he was a high school student. And very few people had that. So he had far more programming practice than almost anybody else of his generation. And that's why part of maybe what creates this quote. You get much better at complicated skills like software in particular, as you practice. Whereas some other things you get better for a while and they kind of max out. So Bill Gates is using the example of a lathe operator. You get somewhat better, but not tons better. But for software, you keep getting better for a long time. He's saying here, the best are much, much better, and there are studies that show this. The best programmers are more than 10 times better than the average. So what does that mean? You'd really like to be one of those extremely good programmers. You'd really like to be at least average, because it's so important nowadays. And the good news is that this skill is made. It's not something that is born. Okay, so as I said, Bill Gates was a great programmer, but it's because he got way more practice than almost anybody else. Who here has heard of this book, Outliers, by Malcolm Gladwell? Anybody heard of this? Okay, a few people. Okay, so if anybody wants to buzz in and tell me what does Outliers have to do with this, feel free to buzz in. I've kind of given it away a little bit. All right, everybody's a bit intimidated to do it. So this book goes through many cases of people who are exceptionally good at a variety of things. Great athletes, great artists, great scientists, etc. And it shows while people tend to think that they were just born that way, that in fact what usually differentiates them from others is that they practiced more. And also because they practiced more, they got better at it, and then they got positive feedback, right? People said, hey, you're good at this, which made them want to practice more. So if you go, I don't think I'm one of these great programmers, and you probably aren't. I wasn't either. What you need to do is practice, okay? It's not something that you were born with. So we're going to give you some practice in this course. Let's talk a little more about the abstract skills of design and communication. So when are you going to use those? The first place, one of the first times you're going to use it after leaving here is getting a job. So I've hired hundreds, maybe at this point 1,000 engineers. You get a stack of resumes and transcripts, and you look at the transcript and you try to get good grades. That's a good thing to do because it looks good on your transcript. But that's just the first thing people look at. It's a first look at a candidate. If the candidate looks reasonable, they're brought in for an interview. Well, you look at their resume and then you bring them in for an interview. And what you're looking for in that interview is not tell me about this high grade you got on this course. You're trying to figure out, can this person design and problem solve? And typically on a problem they haven't seen before. You want to see how they think. And can the person communicate well? Because communication is going to be so essential to a successful career. So my favorite interview questions, one of them is, what is your proudest design achievement? I can tell a lot from that. Somebody who tells me about something complicated, they know how it fits together, they have a passion for it. This is someone that I want to hire because they will have that passion, they will dive in, they will bring that same desire to learn and design to the job I have. My other favorite interview question is, describe a difficult debugging problem you faced. Okay, so why do I ask that? I ask that because nothing that is any non-trivial system, it doesn't work the first time. So engineering is debugging. Engineers make things work. I want to hear this is a person who faces those challenges and overcomes them. Maybe not all the time, right? Some of the stories I got were like this super hard bug and I never figured it out. But the person told me how they attacked it, and it was they dug deep and it was systematic. What I did not like was I asked the TA. I tried random things. I gave up, right? Or I just never faced a difficult debugging problem, because that tells me you never worked on a difficult system. So in this course, you're going to have to debug software, but that's part of the learning experience. This is a key skill. Okay, so that was getting your job. What about building your career? So you're going to take many courses at U of T where you analyze how something works. But and that's important, you need to know that. You need that fundamental scientific knowledge. But in your career, you want to go beyond that as an engineer. You want to create your own designs. You still need to analyze the choices, but design also requires creativity. You know, there is no one right answer, and you have to take a shot. It requires breadth, so usually you're taking things from many fields and putting them together. So that's a difficult skill to get, but you get it through practice. So again, you'll practice in this course. You're going to communicate throughout your career within your team, so status reports, informal, fast communication, to your management where it's more formal, kind of progress updates, and to clients and customers where it's more formal still, right? You gave us a bunch of money, we'd like more, here's why. And we're going to have examples of all of those kinds of communication in this course. Okay, so that was kind of building your career. You could also, many of you might be interested in entrepreneurship. Maybe you want to start your own company at some point, and so that's something that I did. So as I said, I co-founded a startup to create better computer-aided design tools for FPGAs. And that startup, the software that we created, turned into the heart of Quartus 2. So if you've been using Altera's tools, Intel's tools in your ece241 course, you've been using the software that inherited this, came from this. So when we created this company, the first part of it was design. We were going to make better software for computer chip companies, and we were successful at that. Our software ran 30 times faster. So we took things that took 8 hours and we do them in 15 minutes. And the circuits that went into the chip ran on average 38% faster. Okay, well, that makes the chip more valuable. You could sell the chip actually for about twice as much money now. So that had value, and that was our business, right? Selling that we can do this. Okay, so Altera was one of our first customers. They paid us $2 million, not even for production software. The prototype we developed worked well enough that they basically said, we want to buy that. We don't even need you to turn it into like a fully polished software. And at that point, and they wanted us immediately to move on to the next generation chip, because they felt this was very important. And that showed us something. This has a lot of value to them. So we pitched to their CEO and COO, well, we can make software for your next chip, but the chips you're building they're not really the best chips for our software. You should let us design your next generation chip. And we'll design the software to go with it, and that's going to work much better. And we could actually compute what kind of money could they make off of that, and it was billions. And that pitch was successful in that they believed it, and they decided, well, but there's no way we can have some external company designing both our chips and our software and selling the technology all over the place. So that was what led them to make an acquisition bid, which was a good enough deal that we decided to take it and turned into Altera Toronto and then Intel Toronto. So this was a very high stakes presentation, right? You got 30 minutes to make your case of, you don't put this right up there, but the whole underlying message is, this is a good idea, and you should figure out a way to financially make this happen. So it was a very high stakes presentation. Okay, so that's kind of it on motivating. Why are these skills important, with kind of examples from my own career. Now, how many people have read the syllabus in great detail? Nobody? Well, one person, thank you, right? Because we slaved over that. Okay, but I did think maybe some might not have read it in full detail. So this is a very quick overview of what's in the syllabus. So you're making a mapping application. You're going to do 2 individual tasks, right? So I'm going to talk about milestone 0, learning the tools. Professor Chong is going to talk about written document 0, which is learning made to stick. And then the remaining deliverables are in your team of 3. I'm not going to talk about them right now. We'll get to them as we go through the course, but they'll teach you a mix of software design, algorithms, communication skills. Your evaluation is going to be about 50% on how well your software works, and about 50% on how well you communicate and how well you manage the project. Okay, so final product matters, how you get there matters. There's no written midterm or exam, so it all comes from this. You'll be mentored by both a communication instructor, who represents essentially a project manager, and evaluates how effectively you communicate, and a TA who essentially represents an engineering manager and is going to evaluate your design and give you mentorship on that. In the next 2 weeks, you're working on milestone 0. So you have a lab this week. It's not very difficult. You have 2 weeks to basically go through tutorials that we're putting on the course website, debug a simple program, show that you know how to use the software tools. This is less about debugging the program and more about showing your TA you know how to use the debugger, you know how to use the source code control system. We haven't taught you the source code control system. That comes later this week. You're going to work on the ECE UG machines. Details are in the syllabus, but basically there are 4 rooms You log in with your UTOR ID and your student number as the password, and you change that password right away. We've also posted on the course website 2 ways that you can work remotely if you don't want to go to the lab all the time. During lab hours, go there. Your TA expects to meet with you, but you don't have to go there, do all your work there. Okay, 2 weeks are working individually. You're just learning the tools. The start of the 3rd week, you're working in a team of 3. So in the next 2 weeks, you need to find teammates, enter them in Quarkus. Choose wisely, right? So if you look at the little document we posted, we give you some tips, but try to find people who have complementary skills, can get along, and have similar expectations. You know, are you shooting for a high mark, or are you shooting for not doing that much work and getting a decent mark? It's better if you're aligned. You can use Piazza to find teammates, and if you can't find teammates, Professor Chong will help you in the week of January 22nd. But if you can find teammates who kind of match with you well, it's generally better. Okay, we're gonna also be teaching you key concepts in the tutorials. In the first 2 weeks, we're gonna teach you an important library called the Standard Template Library that allows you to build things much faster in C++. You definitely wanna know about this, otherwise the project's gonna take you a really long time. We'll also cover some other hands-on topics in 6 more tutorials throughout the term. You can go see the syllabus for details. Academic integrity. We have no final exam, so it's very important that your work is your own. Don't share code with anyone outside your team. Don't look at or incorporate code from another team or any prior 297 projects. We actually have no discretion in this. As soon as our plagiarism detectors detect a problem, and they're running everything you submit, we have to file a report. It goes to academic integrity. Because this course has no final exam, any academic integrity issues on your communication and your coding assignments are taken very seriously. You don't want to go there, and you'll be penalized even if you just let somebody else see your program. So that's always a sad situation. Don't do that. We keep every milestone that's ever been submitted in this course, okay? So if you have a buddy who took this course a few years ago, or you find something, you say, maybe I'll just look at their project, that's not a good idea. Okay, your CI and TA are mentors. Ask for help. Ask whatever you'd like on Piazza. Just don't post code or solutions unless you make it private. Dr. Chong and I both have office hours. You can also email us for separate ones. There's a lot of support for you in this course. You should reach out and use it if you're having problems. Feedback. There's an anonymous feedback link, so you can tell us to our face. I mean, Professor Chong just gave me a bunch of feedback on my communication, and I think I've improved. So maybe you preferred the way I started the lecture. If you do, you can tell me that anonymously with this link. So if there's something too scary to say, you can tell us anonymously. We like to find mistakes in our materials, so we have a mistake bounty. If you find mistakes, we give you bonus participation marks, and we give you a chocolate bar. Okay, I actually brought some chocolate bars today. If you find 3 non-trivial mistakes in one lecture, we will give the next lecture every person in the class a fun-size chocolate bar. Can't afford full size for that. It has to be non-trivial, because last year the class totally got into this, and like any missing comma, whatever, like they were on it. Okay, so we're saying it's a non-trivial mistake. Missing a comma doesn't count. Okay, workload. So read this quickly. You might recognize this person. He's Elon Musk. He bought Twitter. This is an email he sent out to the workforce. So read this quickly. Okay, we will need to be extremely hardcore, so mean working long hours at high intensity. Only exceptional performance will constitute a passing grade. That is Elon Musk. That is not us. Okay, we are much more friendly than this. We do not expect that. Do not destroy your other courses by spending all your time in this course. You don't need to do that. So what we want you to do is essentially stretch some. This graph basically shows how much are you learning versus pressure. If you have very little pressure, it's kind of too easy. You're just kind of bored, you're not learning much. We don't want you to be there. We want you to feel a bit nervous. So you're stretching, you're doing some things you haven't done before, you're doing them better. So you feel a bit stressed, you're learning a lot. We don't want you incredibly stressed, where you're just worrying too much, you're not paying attention to your other courses because you're not learning that much then, and it's not good for you. This curve isn't just for teaching. This is true of your whole career. In my career, if I did the same thing for too long, I started getting bored, and it was basically because I wasn't learning as much. It was actually a little bit too easy. On the other hand, whenever I took on a new challenge, I was stressed out, but I was actually learning a lot. And I had to make sure I took on new challenges at about the right pace. If I took on too many at once, it was too stressful, I wouldn't learn that much. Try to apply that to this course too. We don't expect perfection, decide how much you can do. Okay, and with that, I'm going to pass it back to Professor Chung. Sorry.
We're going to get better at these handoffs over the course of the term, promise. Let me see here. Okay. Yes. Okay, so I get the privilege of talking about your first assignment already on your first day of classes. Sorry about that, but I have to get you started early. So WD0 is about what makes ideas memorable, and it's an application of this book, Made to Stick, to 3 recent technology-related talks, okay? So what it asks you to do is essentially to take 3 of the principles from this book, okay, to apply it to one of 3 presentations, okay, and to talk about how these principles were used or how they could have been used better to make these presentations stickier. Okay, and the presentations that we have, I think, are really good ones for this year. They're part of the Apple Vision Pro introduction at WWDC 2023. They're Ilya Sutskever's talk on the perils and opportunities of artificial general intelligence and from the TED Talk. And then also the part of Google I/O 2023 that talks about corporate responsibility in their AI products, okay? So this is about a 400 to 600 word assignment that's due on January 27th, okay? Now, I'm just gonna talk a little bit about what this book is, okay? Because we made a very intentional choice in choosing this type of book as opposed to choosing a writing or communication manual or textbook. Now, one of the reasons why we did that is we noticed that as we were kind of assigning these textbooks, not a lot of people picked up these books ever again after the course was over. Okay? What we hope is with this book that you will take something from it, you'll pass the text around to people, you'll talk about it with friends, because it's a different type of book, right? It's a book that uses social psychology, behavioral economics, and helps to explain not just what to do with communication, but how communication works, and why certain strategies or techniques are or aren't effective, and ideas are or aren't sticky, okay? And so really what we want to get to is the idea that if you understand how and why, this is going to help convince you to use these techniques in these courses and in the future, okay? A couple words of warning about this text also. It's going to be really tempting to just read the introduction. Okay, because it spells out 6 key principles that are defined with these words and in this acronym, okay, success, right? And these seem like really common sense principles, okay, when you look at it, okay? But if you look at how they talk about these principles, for example, with the idea of simplicity, simple for them doesn't mean that it's just compact, short, or easy. It's actually a combination of a few things. It's both compact and a core message, a clear core message for you to give, right? And as in a proverb rather than a soundbite, okay? And so the definitions and the descriptions of the principles are really not sufficient. And one of the things that they say is that if something sounds like common sense, it's often the enemy of sticky messages or understanding that message. Because if it's common sense, why do I want to invest any time in understanding it, okay? But the problem with the concepts here is that it's really through the examples in this book, which are spelled out in each of the chapters, that will help you remember the core of the messages in the actual text. So we definitely want you to be looking there. Okay? And we'll talk a little bit about what we did at the beginning of this class, right? We tried to apply two of these principles to make for a sticky message around why communication matters, right? We took the idea of unexpectedness, which is to add a surprising element, and concreteness, which is to give you a explicit, clear, concrete example of something. We put those two principles in the service of the idea that communication matters, okay? And hopefully we did something a little bit surprising to you at the outset of lecture to get your attention, to help convince you that communication matters, okay? And we showed you, rather than just told you, an example of poor communication and what the impact was going to be, okay? So in a way that linked to the core idea of the lecture, and then also we discussed its impact on your impression of our authority, okay? So what we're hoping for is that you can take a look at these principles, understand what they mean, and understand how they've been used and how we might use them better to communicate a little bit more effectively. Okay? So how are we going to apply these? So in these, in each of these deliverables, you're taking really two different approaches. The first will involve using made it stick to analyze or justify your communication strategies. And the second will be employing strategies from made it stick to your actual presentations and written documents. Now, the green box you'll be doing in everything, right? But certainly in WD0, the goal is analysis, and so you'll be doing the analysis of communication strategies, and absolutely in OP2, we will ask you specific questions about which made-to-stick principle you used in your oral presentation. Okay, so ultimately, what do we want you to do with make it stick? Okay. We know you've had instruction in technical communication already in APS 111, 112. But that instruction has been really highly specific to a particular context. You're writing a very specific set of genres that are very well defined. You have a clear set of instructions. And it's been more like a how to do this effectively, okay? Now, the problem with that instruction in APS 111, 112, and it's good technical information that you need to know how to communicate in that particular way. It's very highly specific, right? And you're not going to get that level of specificity in industry, right? No one's going to tell you how to write the report. You're going to have to figure out how to do it, okay? So what we want you to take from this course in this book is a set of principles to apply everywhere, okay? To understand the why as well as the how behind good communication, okay? And how the use of your engineering judgment is really key in applying these principles and concepts in a way that's genre and context independent. So that when you're given a new communication challenge, you're able to apply those concepts in a smart and intelligent way that improves your communication. Okay? So ultimately, we do care about what you do in this course. Okay, obviously we want you to do well on your oral presentations and your written documents, but ultimately the goal really is transfer, okay? So for you to learn and practice in 297, but to take the concepts in this book and actually internalize it for the communication you do outside of this classroom and in the rest of your academic